Hi everyone, it's Paul, W2PAK. Today we're going to measure inductance and capacitance accurately. I'm building a diplexer as part of a quad antenna that I'm designing, and I've been hand winding these little inductors, and I need to accurately measure what the inductance is. I'm going to show you how to do it. Come join me. Today we're going to use a nano VNA such as this one to measure the inductance and capacitance. So you know that the nano VNA can measure impedance, which is R plus minus JX. But if you're looking just at the impedance of, say, an inductor, then ZL is J omega L, which is J 2 pi F times L. The impedance of a capacitor is minus 1 over omega C J. And this is minus J 1 over 2 pi F times C. So you can see that if we can measure the impedance of the inductor and the capacitor, we know the frequency, the VNA of course knows the frequency, then you can extract the L and the C. And that's how the VNA does it. My VNA actually has an inductance and capacitance measurement, but if yours doesn't, if you can measure X, then you can find this with a simple formula. I've seen people measure inductance with these little alligator clips. The problem with that is it's not very accurate. If you move these connections, even if you calibrate it, the calibration is going to change. And so what I ended up doing is building a little box like this one. It was very simple. This is just on Amazon. I got a little plastic box and I bought these little banana connectors and a cable. My VNA uses an N-type connector. And the nice thing about this is it's steady. It doesn't change. And so if you calibrate this properly, then you can very accurately measure the inductance and capacitance. You could use something like this if you wanted to. This would work. But my inductors are rather large, and this just wasn't big enough, and I'd have to kind of smush my inductors. So I didn't want to do this. So let's start with how we measure this. So the first step would be to calibrate. So you go to calibrate, and then you press open, and then it would calibrate. You do short. You just put a wire between these two at calibrate, and then I put a 200 ohm 0.1% resistors in parallel to get a nice 50 ohm load, and I calibrated. So I'm not going to do it right now because it's already calibrated very nicely. And I saved my calibration in this little file. And so I have a store-bought or pre-wound 560 nanohenry inductor, which I'm going to put in these little terminals. And you're going to show you how to measure it. And you can see things kind of settle down where that happens. You know what, I'm going to zoom in a little bit so you guys can see the screen better. Right, I think that's better, huh? Okay, so I set this up for 3 traces. The yellow trace is the phase, the blue trace is the inductance, and I did also the Q, and I'll show you how to set that up. So if you go to display and you have different traces and you select the trace you want, and then under format, you're doing S11, so you're using the S1 port. And then you can do phase here. You can do Q factor, or you can do series L. You don't want parallel L, you want series L. So that's how you set up these different traces. Now, I'm going to move the phase to 90 degrees. Why 90 degrees? So you remember the Z equals R plus JX. So the J symbolizes 90 degrees out of phase. So this is at 90 degrees out of phase at this point. You can see 90.1, close enough. And then it reads out the inductance. So this is 535 nanohenries. So that is that measurement. It's very easy. And now I can, you can't see, but I'm moving the box around a little bit, and it doesn't change a lot because it's very steady. So this little coil I made, I'm going to kind of sneak it in here. That one, I'm going to put it in right now. And again, you can't see, but I'm zoomed in because I want to show you the screen. So I'm going to put in this little coil, and I designed it to be 1.25 microhenry. So you can see, first of all, that the Q is much higher. But also you can see that we're at 48 degrees. So let's move other way. Let's move to 90 degrees. 92, 90 point, there you go, 90.1, and it's 1.18 microhenry. Now I can change the inductance a little bit by squishing this or separating it. There you go, now it's 1.2. Yeah, so pretty good. So now we're going to measure capacitance. So I just put in a capacitor that's 2.2 nanofarad. So here's how we set it up. So I'm going to shut off the green trace because I don't care about the Q. I'm going to leave the yellow trace as the phase, and then the blue trace I'm going to set to series capacitance instead of series inductance. And so now you'll see the phase is minus 67, minus 70. So I'm going to go up, and there's 90.9, close enough. It's minus 19.9. Remember, it was minus J over omega C. And so this is 2.14 nanofarad, close enough. It's supposed to be 2.2, and I think it's a 5%er, so that's within tolerance. And that's how it's done. So this is pretty easy to do. The big deal was to set up the box. That took, I don't know, 15 minutes. But once I calibrated the box, this was very, very accurate. Hope you found this useful. It was very helpful to make my inductors for the diplexer. I'll make another video about the quad antenna and the diplexer I'm designing. But I thought I'd make a little video on how to measure inductors and capacitors. 73, my friends.